We will start the psychometry and air conditioning process. This is the fifth chapter or fifth topic in continuation with the previously completed four topics. In the psychometry and air conditioning process, it is a preliminary course for aeronautical engineering students, as initially we'll discuss the properties of moisture. Then in the property of moisture, specific properties like three temperatures: wet bulb, dry bulb and dew point temperature, apart from humidities, specific relative humidity and degree of saturation will be discussed, although there are more properties which needs to be discussed, but we will discuss only the important properties. Then how psychometric chart is used while calculating the air conditioning system, designing air conditioning system. So a brief overview will be given. Then the psychometry of the air conditioning process, different psychometric processes which can be coupled with the psychometric chart or on a molecular diagram and can be evaluated based on the given conditions. So that part will be discussed in this particular part, and in last we will see the mixing process when different type of air streams and cold or hot air stream will mix, then how the air conditioning setup will look like, that will be discussed. First of all, now the refrigeration is the part that previously we have discussed. Now it's the air conditioning process. So in refrigeration, what we have controlled, we have lowered the temperature, we have cleaned the air, I mean the concentration of contaminants is lower, and also we will maintain the air velocity as per the requirement of refrigeration. Now in air conditioning, the psychometry is important because it's a science which is related with the study of thermodynamic properties of moisture to analyze the different condition and processes for air conditioning. Now air conditioning can be applied for a large variety of products as well, apart from industrial air conditioning. Generally, industrial air conditioning is known as to create a cooling or heating, or HVAC, heating, ventilation and air conditioning in a residential as well as commercial offices, you can say. Now apart from this heating and cooling process, that can be applied to the drying processes, flue gas condensation, like in the different type of thermal power plants as well. So apart from residential and commercial apartment or complexes, it can be used some specific applicable industrial application to create a particular type of products. Air conditioning is generally categorized as AC, or preferably known as air conditioning or AC. It is a process of altering the properties of air, primary temperature and humidity to the comfortable conditions. Initially the comfortable conditions was 24 degrees centigrade and 50% relative humidity and approximately 0.2 meter per second. Air velocity was treated as comfortable condition according to the guidelines provided by ASHRAE. ASHRAE is the American Society of Heating, Refrigeration, Air Conditioning. Now it is slightly increased to 26 degrees centigrade. So comfortable condition with the aim of distributing the conditioned air in a specific space or a zone of a vehicle or a building or a large occupational area as well. So it is used to improve thermal comfort and indoor air quality. Now once we define air conditioning, we need to define the capacity of this particular air conditioning, because if the area is large, the larger capacity is required. Small area, smaller capacity is required. So BTU is the preferable unit which was used since 1945 to 205, or you can say up to now. So BTU is the British thermal unit, in short BTU. So a BTU is the amount of heat required to raise 1 degree temperature of a pound of water. So if you buy air conditioner which is rated 10,000 BTU, it means it has the ability to cool 10,000 pounds. So 10,000 pounds will be equal to the 1200 gallons of water, 1 degree in an hour. So what here, now refrigeration is normally measured in tons, and 12,000 BTU, which is 12 equal to the 1 ton. Now, before we start the psychrometry of air conditioning process, we need to understand the difference between latent heat and sensible heat, superheated and saturated vapors, and subcooling and superheating as well. So these topics we have already discussed previously. Like latent heat is the heat given up or absorbed by a substance as it changes state, and sensible heat, when added or removed, causes the change in temperature but not in a state. Similarly, superheated vapor means above the saturated line. Saturated temperature means boiling point or condensation temperature, where refrigerant will change state from a liquid or vapor to liquid as well. Subcooling is important to measure subcooling because it's the liquid does not stay in the condenser. The greater the sensible heat losses. Now this is the properties of moisture. So very specific properties are covered, starting from the first one, the humidity. So the difference between the household coolers, basically, which is used in summer in less humidity area, and air conditioner is that the cooler can control the air velocity and air temperature, but it cannot control the air humidity. Very simple, everybody knows. But air conditioner can the air humidity. Now what is this humidity basically? So humidity is the quantity of water vapor present in air. It can be expressed in terms of absolute, specific, or relative humidity. So specific and absolute are the more general terms, which is first of all the ratio of water vapor present in the moist air to the mass of dry air. So when air is flowing, it contains some water vapor, some doesn't contain any water vapor. So mass of dry air to the mass of water vapor present in the moist air is the humidity ratio basically. Now first term is over. Second is specific humidity. Specific humidity is the ratio of water vapor contained in the mixture to the total air contained on a mass basis. Simple. And the one we were talking about with respect to air conditioning is relative humidity. So at dew point condition, which is 100%, the relative humidity is the ratio of the amount of water vapor which is actually present in the air to the maximum amount that air can hold for this separate condition. So in general terms, generally we can understand that the amount of water vapor which is present in the specific amount of air, that if we are talking about the ratio, that's a humidity ratio. If we are talking about the ratio of water vapor contained in the mixture on mass basis, then it's a ratio of same thing, water vapor of that particular moisture and dry air. So if we are talking about the on mass basis, it's a specific humidity, otherwise it's a humidity ratio. And if we are talking about a dew point condition, it is known as relative humidity. In that particular condition, because it's 100% relative humidity, it means it should be to the maximum amount that can air hold under these conditions. So these are the specific, relative, and humidity ratio definitions. Now temperatures. Dry bulb temperature basically is the normal air temperature. So we can just put the a normal thermometer and we can measure the temperature. It's a dry bulb temperature. Wet bulb temperature is the method of measuring the temperature with the thermometer, which has a bulb covered with the moist cloth, and this moist cloth thermometer can be placed in the flowing air stream and the temperature will be measured. Similarly, dew point temperature is the temperature at which water vapor begins to condense. That's it. Three temperatures. Now wet bulb temperature will never be higher than the dry bulb temperature. Obviously dry bulb temperature is the normal air temperature. Wet bulb temperature is the temperature which is once it is moistened with the air water cloth. And the last definition is the degree of saturation. So degree of saturation is the ratio of humidity ratio of moist air to the humidity of saturated moisture. So ratio of humidity ratio moist air to the humidity of saturated moisture and saturated moisture. And degree of saturation ranges from 0 to 1, while relative humidity ranges from 0 to 100. 100% relative humidity means you will be achieving the dew point. Dew will be start for. Now this is the actual representation of different processes on a psychometric chart. So there are two figures, one colored, other one is the black and white figure. On the colored figure there are several lines, blue line, red lines, dark blue lines, black lines as well. So first of all, this is basically psychometric chart. So it's a graphical representation of all type of psychometric properties at standard atmospheric pressure. So in the base, on x-axis, this is dry bulb temperature, which is in degree centigrade. So if we go for y-axis, basically it's a humidity ratio, grams of moisture per kilogram of dry air. So this vertical y-axis is humidity ratio, horizontal axis is dry bulb temperature, and this inclined axis, it is the enthalpy scale. It will give you the enthalpy values. Now this enthalpy values are basically straight inclined lines on y-axis as well as on x-axis. Simultaneously, this small scale on extreme left side of this figure contains some red lines, red curved lines, and which is curving towards the uppermost side. These curved lines are the relative humidity lines. Okay. And starting from uppermost side, this is 0, and for lowermost side, this will give you the definition of 100% relative humidity. So now vertical lines, there are a few vertical lines as well, and these vertical lines representing the simple temperature, dry bulb temperature, which is your x-axis value. So dry bulb temperature, humidity temperature, and relative humidity, and enthalpy values, this is the lines. One point is left, which is basically dew point temperature. So if you switch over to this figure, which is simple black and white lines in the left side, it will give you some idea. So this is enthalpy values, then humidity ratio, dry bulb temperature, and some slightly specific volumes lines as well. This is the wet bulb temperature line and dew point temperature line. So inclined curved lines parallel to the enthalpy scale are the dew point temperature lines. So once you go for the actual psychometric chart, the things will be clear. So this is actual psychometric chart basically. So in that chart, the temperature scale can be clearly seen. It is start from this 40, 50, 60 up to the 100, 10 or 120. So this is a dry bulb temperature line. Which one? The vertical lines. Similarly, humidity ratio lines are the horizontal lines. So 0.04, 0042, 0.028 are these are all the humidity lines. Similarly, now the enthalpy values. So in fact, we can have the SI units as well in the psychometric chart. So it starts from 15, it ended to the 50. So all these lines are basically extended up to x and y axis. Similarly, the curved lines, these are the humidity ratio lines. Okay, so I mean relative humidity lines, and then the inclined lines, the specific volume lines. So 135, 148 or 14.5, whatever these lines are values, up to 15 or start from 12.5 basically. So 1, 2, 3, 4, 5, 6 lines are there. So this will give you the values. Now why and how these values are useful, so that we'll discuss. So what you need to understand, just remember the out boundary of this diagram, which is inclined, small vertical, then horizontal, then long vertical, then small horizontal. So 2 horizontal, 2 vertical, and 1 inclined line. That will give you the overall idea of psychometric chart. Now this is the mixing process, other basic process that can be represented over the psychometric chart. Remember, 1 horizontal, long horizontal, long vertical, small vertical, and 1 inclined line. So in that manner we can represent the psychometric chart. Now air conditioning process. So the most common air conditioning processes are heating of air, mixing of air, cooling of air, or humidifying or dehumidifying air by adding steam or water vapor in it. So on the psychrometric chart, you remember there are several lines are there with different values. So we'll consider the, on this right side of the figure, we'll consider center point here, which is known as O point. So if any values which is given or being asked is moving from in horizontal line, it means we are dealing with the heating condition. In opposite, if we are, the values will showing the movement from right to left time, this blue line side, then it means we are dealing with the cooling condition. Similarly, upper side humidifying, lower side dehumidifying. Now between heating with the red and green line, so it's a heating and humidifying, because heating is on right side and humidifying on the top side. So heating and humidifying on the this axis, red and green. Similarly, green and blue, cooling and humidifying. Then blue and this green is cooling and dehumidifying. Similarly, red and green is heating and dehumidifying. So these are the process which can be represented of the psychrometric chart. If the values are given, psychrometric chart is known, we can just trace out the values and identify the process. Or reverse, the process is given, we need to trace out some values, so we can trace out the values. So vice versa we can do from the psychrometric chart. We can identify either the process, or we can identify the initial or final conditions. This is some example of mixing process and other basic process in the conditioning of air. So now there are two type of diagram, which is on upper side and the lower side diagram. Upper side diagram is known as Mollier chart, and lower side diagram is the this inclined line of the psychrometric chart. Okay, so in this psychrometric chart line, if we look carefully, there are two processes which is given on the enthalpy line. So enthalpy can be represented by H, because two range of enthalpy, we can say A and B, so we can represent the change in enthalpy as dH. So A process is the initial process, because arrow is starting from here, and B is the final process. So A to B, if you go back to the previous slide, you will understand this A to B process is the heating process, red line, remember, and this is the horizontal process. So it means this process is the horizontal process. Now what is there? Heating air. So heating air can be represented on this psychrometric chart, which is nothing but the state A to state B along a constant specific humidity X line, because on vertical axis specific humidity lines are there, or humidity ratio lines are there. This specific heat is supplied at the dH to the air as indicated in the Mollier diagrams. In the Mollier diagram, if we remember, this Mollier chart basically is again representation of enthalpy, specific volume, entropy diagrams with respect to pressure and temperature values for air. So specific heat supplied, and dH is represented over here with respect to A and B with temperature A, TB and TA. So the air heating process can also be expressed similarly on the Mollier chart as well as on the psychrometric charts. Whichever feels comfortable we can express, because we are continuing with the psychrometric charts, it's better to continue with the psychrometric chart only, so the process can be easily be identified. So this is the process of heating air. Next example is the mixing of air into two different steps. Now in this particular diagram, A to B and C to B, so one process is basically heating and humidifying, and second process is cooling and dehumidifying basically. So A to B and C to B. So what is happening here? We are increasing the enthalpy there, we are decreasing the enthalpy here. So when mixing of air from state A to C, the mixing point will be on the straight line between the two states, that is point B. So from A it is coming to B, from C it is coming to B, somewhere they are going to mix it and giving the final condition. The position of point B depends on the volume of air and state A. So what we need to do two balance equation. One is heat balance, another one is the Maillard balance from steady flow energy equation. The heat balance for the mixture can be expressed as mass and enthalpy at point A plus mass and enthalpy at point B equal to mass of A plus mass of B and enthalpy at point B. So if we are able to identify the point B, we can easily calculate the enthalpy value on the psychrometric chart. So mass of air, heat of air. So moisture balance also can be expressed with respect to A, then C, then the mixture. So X, what is X here? X is the specific humidity the air. So this is another process. Basically this is saturation curve. So it's a representation of mixing process. When hot air is mixed with cold air, it results fog, and the condition of formation of fog is only if the mixing point is below the saturation line of the air. So when there is a fog, part of moisture in the air condenses a small droplet floating in the air. The process can be explained in the Molly diagram. So basically just below the saturation, if this is going to hang just below the saturation line, it will create some fog. So if we further heat it, fog will be removed. So heating means we need to shift this point V towards the lower side. That's it. Now this ends the basic psychometric and air conditioning process. Next we will start the comfort conditions or human comfort.